Dear students, yesterday we discussed how to find the area under a curve by using the definite integral. Now today we will discuss the questions from the first exercise, and the question is, find the area of the region bounded by y square equals to 9x, x equals to 2, x equals to 4 and x-axis in the first quadrant. Here the given curve is y square equals to 9x, which implies that it is this right-handed parabola, that is this parabola. X equals to 2, sorry, here it is x equals to 1, that is this axis, this line, this one, and x equals to 4, this, and the x-axis. So we have to find this area of ABCD, because this area is enclosed by curve y square equals to 9x, that is this, from this, x equals to 1 and x equals to 4. Now if we consider here this vertical strip with length y and width equals to dx, then from given equation y square equals to 9x, y equals to root 3 root x, then clearly area of this rectangular strip is dA, which is y dx. So the required area is, we have to integrate given y from limits x equals to 1 to x equals to 4, that is 1 to 4 y dx, that is 3 root x. After solving this and by integrating x raised to power 1 by 2, we simply get 14 units. So 14 units is the required area which is enclosed by the curve y square equals to 9x, line x equals to 1, line x equals to 4 and the x-axis in the first quadrant. But if we are asked to find the area enclosed by curve y square equals to 9x, line x equals to 1 and x equals to 4, then we have to determine, or then we have to find this whole area. Now this whole area is simply twice the area of ABCD. So simply if you are asked to find the area in the first quadrant, then you have to solve in this way. But if you are asked to find simply the area between x1, x equals to 2, x equals to 4 and y square equals to 9x, then you have to multiply this area by 2, because this parabola is symmetric about x-axis. Now find the area of an region bounded by x square upon 16 plus y square upon 9 equals to 1. Clearly this is the parabola, this is the this ellipse with major axis, semi-major axis a equals to 4, b equals to 3, which is the minor axis. Then coordinates of vertices, that is this a, or 4 0, because the semi-major axis is 4 and it lies on the x-axis, because the denominator of x square is greater than the denominator of y square. Now the coordinates of this center are 0 0. Now from given equation, if we consider here the vertical strip y equal y and dx, then this area of this strip, that is elementary area, is here dA is simply y dx. Now we will firstly determine the area of this region in the first in this quadrant, that is area of region OABO. Here any point on this curve is of the form of x square upon 16 plus y square upon 9 is 1, that is y equals to 3 by 4 root 4 square minus x square. So substituting in this, area of the region AOBA is simply by integrating it from 0 to 4 y dx, that is 3 by 4 under root this integral from 0 to 4 root 4 square minus x square. But this ellipse has 4 equal parts, means area of the whole this ellipse, area enclosed or region bounded by this ellipse, is simply 4 times the area of this AOBA, that is 4 times 3 by 4 integral 0 to 4 root 4 square minus x square, that is simply thrice integral 0 to 4 root 4 square minus x square. Now this 4 square minus x square is standard integral. It is here a is 4 and x is x, so using the standard integral, it is a equals to, means required area, 3 times x square upon 2 root 4 square minus x square plus 4, that is a square, 4 square upon 2 sine inverse x by a, means x by 4, from limit 0 to 4. which implies that after substituting 4 and 0 we simply get 3 into 8, that is 23 into 8 sine inverse sine pi by 2, because sine 1 is sine pi by 2, that is simply 3 into 8 pi by 2, which is 12 units. So from this you can also, by the same method, you can also prove that the area under the ellipse x square upon a square plus y square upon b square is 1 is simply pi ab, means pi into product of the semi-major and the semi-minor axes. Here semi-major axis is 4, semi-minor is 3, that is 4 into 3 is 12, that is 12 pi units is the required area of under this ellipse. Now the another question is, find the area of the region in the first quadrant enclosed by x-axis, line x is equal to root 3y and the circle x square plus y square equals to 1. Now we have to find the area bounded by these curves. Firstly, we have circle x square plus y square is equals to 4. Here radius of this circle is r equals to 2, which implies that coordinates of this a, because it is an endpoint of this diameter, or simply the endpoint of this radius vector, it is 2 0, because radius is 2. Also the vertices of this coordinates of this center are 0 0. Now the intersection between this line, because this x equals to root 3y is simply a line passing through origin, so this means that it intersects the circle at 2 points b in first quadrant and in third quadrant. But we are asked to find the area in the first quadrant enclosed by these curves, so this means that firstly we will find b. How to find b? Here x is root 3y, substitute in the given equation of circle, we get y equals to plus minus 1. But in first quadrant y is positive, x is positive, so rejecting y equals to minus 1, which implies that when we put x, y equals to 1, which implies that x equals to root 3. So these are the coordinates of point. So we have to find area enclosed by this, so this means that we have to simply find area of this sector, Now we can draw here line through this root 3 and 1, that is b, perpendicular to the x-axis. Now here we have two types of curves. One from this O to B, this is a straight line, and here y is of the form of root x by root 3, so this means that y is root 3y. Hence area under this is simply integrating x by root 3 from 0 to root 3. Now again we have another curve here from B to A, and any point on this is of the form of y equals to root 4 square minus 4 minus x square, that is 2 square minus x square, while we have to integrate it from root 3 to 2. So find these two definite integrals, sum up these two integrals, we will get the required area. So required area is simply by integrating this x by root 3 from 0 to root 3, and then again integrating y equals to root 2 square minus x square from root 3 to root 2. So this is the required area. So inshallah in tomorrow's video lecture we will discuss few more questions of this very exercise. So thank you.